Hello, people. I got a puppy in here, so I might be distracted. Which, if we're being honest, it's not really any different than normal, is it? I'm pulling up chat, and we're going to finish. We're doing geometry. Misha, hush. Be quiet. Here. We're going to finish our chapter. Okay, so we have one section. It's about spheres, which are important because we live on one-ish, approximately one. Not that there's more than one, it's just not really a sphere, right? So we're going to talk about two formulas. We'll do a few problems, and we'll be done. It should be 20 minutes or so. That's good. Okay, so spheres, right? And this is the last thing in the chapter. We have two core concepts here. So here's our student journal. It's in the Dropbox folder again. Should have access to it to do the problems or anything else. We have two things about spheres. We have surface area, which is like how much stuff can you put on it. It'd be like how much land covers the Earth. That'd be part of the surface area, right? And then the water would be the rest of it, right? And there's stuff besides land and Earth, but and then in water, but everything covering the planet, right? Or how much paint could we paint on the moon to make it blue instead of gray, or whatever color the moon is? Okay, so that's the surface area. It's the outside space, and our formula is marker. Surface area is 4 pi r squared. So pi r squared gives us an area. Pi r squared is just the area of the circle. Well, 4 of those circles would be the surface area, the area that covers the sphere. Okay. So that would be this screen. So, whoa. Why isn't my camera on at all? What the heck? Well, it was working a minute ago. There we go. Okay, so surface area is 4 pi radius squared for our sphere. Okay, so we have our sphere. There's a circle kind of in the middle of it from the equator. Back here, it's kind of this. It's clearly not a perfect sphere, but this would be the radius, and it's the same radius everywhere, which is what makes it a sphere. Okay, and so we'll do some problems with that. We have these. Find the surface area of the solid. So we're going to do 2 of these. We'll do number 1 and number. Okay, that's fine. So the first one, we got 5 centimeters. So what's the surface area? And the radius is 5. So we do 25, right? 5 squared is 25. Okay. Radius is 5. 5 squared is going to be 25. So 25 times 4 times pi is 100 pi centimeters squared. Would be our surface area. So that's like 300.1, right? Square centimeters, which is not super big, but it's a lot bigger than 5. We'll multiplying things get bigger. Okay, so that's the first one. We're going to do number 4 here. So number 4, it just wants half of the circle. That's the top pole, the top half. So number 4, we have half of the circle, and the radius is 11.2 meters. So for our formula, it'd be 4 pi 11.2 squared. So we're going to need a calculator, right? So we would go to Desmos or Google. Shoot. Here we are at Desmos. And then we would do, so it's 11.2 squared times 4 times 5. So that gives us 1,576 meters squared. Meters. 1,576.32 going on meters squared. Or you could leave it in terms of pi, and you would get, just delete the pi from our calculator, you get 501.76 pi. Those two things are all equal, all the same. Okay? So that's surface area. That's like how much stuff covers the outside. How much dome do we have here? If we were like building a Martian base and we needed a some material to make a dome, how much material do you need? Well, that much. If it's going to be 11.2 meters, which is not huge, but it's also not tiny. Okay. Oh, but I forgot something. This is just our normal equation, right? So I forgot. We have to cut this thing in half, so we need to divide this number by 2, and this number by 2 as well. So it's going to be half as big. So that's going to be like 500, 250, right? So it's actually half, because half a circle, half a sphere. Okay? So that one's pretty easy. That's just the surface area. Just plug it into the formula. The other thing that we want to be able to do is find the volume. And the volume is a similar formula. It's also got a 4 in it. But it's going to be 4/3. So the cone for the pyramid was a third. This is 4/3 pi r cubed. So volume, we need a cube. We're going to cube the radius. Wish this showed up better, but you can look at it. So for volume, it's really similar to the surface area formula, except we have to divide that 4 by 3, and then we're going to multiply by another radius. So we get this one. 4/3 pi r cubed gives us how much stuff. How much stuff can we put in our sphere? How many gumballs are in the gumball machine? I guess you guys can see this very much. But how many? Yeah, I don't know. How much air is in the balloon? Perfectly round balloon. How much balloon is? How much stuff do I need to pump up into my basketball? Or how much stuffing do I need to put in the baseball? Fill it. That's what. Hey, Misha. No, don't chew on that. Hey, no. No. Okay. So, to do this, we're going to go back here. And we have some practice problems. So here we want to find the volume. Okay, so it tells us the radius, or here's the diameter. So we'd have to cut that in half. We will do 2 of these. So we'll do 5 and 7 here. So for number 5, the radius is half of 15, which is 7.5 inches. Okay, so 7.5 inches. We're just going to plug that in there. So it's 4/3 pi 7.5 cubed, and we're going to use a calculator. Okay, so I'm going to do this in terms of pi. Here's Desmos. It's a previous function. We're going to do 4 divided by 3 times 7. 7.5 to the third power. So that's 562. Okay. Or we could multiply it and it'd be like, so this is in inches, cubic inches, to this volume. Okay, and then the other problem I wanted to do was this one. Oh, sorry. So here's my answer. 562.5 pi inches cubed. Keep the cubic inches. Okay. And then the last thing that I want to do is this. We'll do number 7 here. It's basically the same thing. So now our radius is in centimeters and is 3.5. And we would have done this all in class. So we get 4/3 here. 4/3. Our radius is 3.5 centimeters. Pi 3.5 cubed, and it's centimeters cubed as well. We would take that to our calculator, and we would just change this to 3.5. And so we get 57.16 repeating centimeters cubed. Okay. So that's it. Using those two formulas, the volume formula, the surface area formula, that gives us formulas for volume of cubes of rectangular prisms. Gives us surface area for those. We should be able to figure that out, solve for each side, and add them all together. Pyramids, surface area is the same. Find the area of the base. Find the area of the area of the triangles on the side. Add those all up for the surface area. We had a formula for the surface area of the pyramid. Use the height and the base and 1/3. We did volume and surface area of cylinders. We did volume and surface area of cones, which were like pyramids. We did volume and surface area of spheres. We did area of circles and volume of cylinders. A lot of formulas in this chapter. They're all in the chapter summary. Normally we'd be taking a test. We're not going to do that, right? But that's it for this chapter. On Tuesday, we are going to start probability. Okay, so probability on Tuesday, and that'll be it. Okay. And that's it. Good to talk to you guys. We'll do a Zoom call tomorrow, which I didn't mention. We'll do a Zoom call tomorrow. You'll be getting an invite on your email on that later. So you'll get an invite in your Fresno Unified email. Not mandatory. We're just going to hang out for maybe 30 minutes, maybe less. Check in. Because we've only got 3 weeks left till summer break. It's all weird right now, right? So I'll see you guys tomorrow.